瓦上的波霜，窗前的月光，都照亮心底某个地方。有人用思念两段促使航，流淌过1000年，恋恋难忘。你有绿树红墙，寄握着风霜，也有草长白云白，吹到长城长。天水煮小巷，早上老火汤，在家3分时光，坐在门前慢慢唱。人间烟火山河浩荡，清风过大江，水路弯弯连海浪，两岸千里的花香。你爱的人啊，记得你最好模样，你是大宝的忠贞，是心之所向。哇，こんにちは、おはよう、こんばんは，早上好，中午好，晚上好。Good morning, good afternoon, good evening. Your favorite algorithm? Really? So today we are doing trees. We're starting to go into trees. So trees, one of the algorithm is breadth first search. To put it simple, is basically you want to traverse through a tree structure level by level. So in this case, you want to traverse 1 first, and then 2, 3, and then the rest is 4, 5, 6, 7. You do that in an order. So let's get into the question while I wait. Given a binary tree, populate any array to represent its zigzag level order traversal. You should populate the values of all nodes of the first level from the left to right, then right to left for zigzag, then right to right for the next level, and keep alternating in the same manner for the following level. Oh, okay. So breadth first search except you zigzag. So normally you go from left to right, left to right, left to right. But this time is left to right, right to left, left to right. Okay. So I think this is still pretty simple using a direction. So I'm gonna create a stack, and then I'm gonna put rule in the stack, and then I'm gonna set a reverse just to dictate the current direction that we are going. You like to explore things equally before going further, especially when shopping. I mean, it's good to see all the options first before deciding. Yeah. So while the stack is not empty, right, we're gonna traverse through the stack. So we're gonna let the node equal to stack dot pop. Actually, wait. less size equal to stack dot size. Multiple size. Stack dot length. So we're gonna for let I equal to 0, I less than size, I plus. This is to ensure we want to visit the all the stack at the current level first, because the question is asking us to compute, to create a subarray for each level. So this is to dictate we have traversed to the level or not. So I'm also gonna set a value so we can store. Hello, Simon. So let node equal to stack dot pop. And then we're gonna push the value. Value dot. I should know where to push. Value dot push node dot value. And then if the node has left, if the node has a left pointer, we're gonna push that to the stack. Stack dot push node dot left. And if the node has right value, we're gonna push that to the stack as well. In the end, let's see. If reverse, then we're gonna actually I want to do it at the end. If reverse, then val dot reverse. And then at the end, we just push that value into the result. Result dot push without. Want to push the val, and then we also want to reverse equal to reverse. So this should give me a zigzagging. I think there's a way to do this without doing this. Like creating two, but I think this is fine. So run this. Okay, now that's weird. I think this one is this. 12719. My SL looks different. Oh, it's not pop. Shift. Run again. Correct. Submit. Correct. Yay. I should be removing from the beginning of the stack, not the end of stack. So that's the whole difference. So let's see what the answer is doing. Yum 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 yum. Left or right, true. If left or right, you push. Otherwise, you unshift. Yeah, basically similar instead, all I did was push, and then if it's reverse, then we just reverse the string. And then they do a not left to right. So basically the same. So breadth search, again, breadth first search is we set a root node, and then while we push the root node to a stack, while the stack is non-empty, we're gonna look at the we're gonna push that value into the result, and then while the before pushing, we're gonna increase the stack. Like we first move away from the stack, and if there are left or right pointers, then we're gonna push left and right pointers into the stack. And then we're going to the next iteration. So next iteration will be we finish one stack. We shift 7 out of the stack, and then push it to the new array of the result, and then we shift 1 to the stack. So if 7 has left and right, in this case there's only one pointer. We push that in the stack, and then for 1 we also push these 2 in the stack. Since this one they want us to zigzag, so we have a reversed flag. If it's reversed, then we just push it in the opposite direction. And then after this is done, we go to the next iteration. So this is how you traverse from one level to the next level. And that's how the breadth first search algorithm is. That's how the breadth search algorithm is, basically. Alright, next. Level averages in a binary tree. Given a binary tree, populate an array represent the average of all its levels. Average of all its levels. Oh, so you just add these together and then you... Okay, that's easy. So basically the same thing, except instead of us pushing this value, making this into a subarray and as hello value, we just sum this value and then divide by whatever the size is. So same thing. We're gonna make a stack, let stack equal to, and we put root into the stack. And then while stack is non-NP, I understand everything I don't understand. Understandable if you're not computer major, I guess. Well, stack.length, we want to look at the stack size. Let size equal to stack.length. For let I equal to 0, I less than size, I plus plus. So in this case, we want to look at the sum. So let sum equal to 0 first. We're gonna look at the node. Let node equal to stack.pop. Actually, no pop, shift. Actually, in this case, doesn't matter because all we care about is the order. Sum is equal to sum plus node dot value. And then if the node has left value, we're gonna push that to the stack. And if the node has right value, we can also push to the stack. Node the right. And then in the end, we want to push the result. Result dot push. In this case, we do sum divided by size. I think that's it. Submit. Correct? Submit. Correct. Yay! Oh my god, I'm doing it so fast. Or even though it's an easy question. So basically doing the same thing, instead of making a subarray, we just do it. We just adding the values into a sum. And then in the end, we just divide that sum. Since we initialize the sum... Wait, do we initialize? Yeah, whenever we go to the next level, the sum always gets reset. Next. Next. Minimum depth of a binary tree. Given a rule of the binary tree, find the minimum depth of a binary tree. The minimum depth is number of nodes along the shortest path from the root node to the nearest leaf node. Minimum depth. Okay, so I think this one, for this one, we also doing the level traverse. For each level that we move into, we're gonna increase the depth by 1. And whenever we encounter... by the time we encounter a node that we cannot go to left and right, we just return the depth. Okay, I think that should work. Again, we're gonna create a stack, and we put root into the stack. And while stack is no empty, in this case, we don't even need to push anything. So let's size equal to stack dot length. For let I equal to 0, I less than size I plus was. In the beginning, we want to do minimum depth plus plus. So let I equal to 0, I less than size I plus plus. We want to look at the node. Actually, this should just be constant because I'm not changing the values. Constant node is equal to stack dot shift. We want to make sure that the node have no node. It's the shortest if we encounter a node that we cannot traverse anymore. So we want to look for if there's no left and there's no right, then we just return the minimum. Otherwise, if nodes dot left, we push the left to stack. If nodes dot right, we push node dot right to stack. In the end, yeah, I think that's it. Submit. Accepted. Submit. Accepted. Yes. Yay! Oh my god, I'm speeding through all the questions. Suddenly I feel so smart. Good morning, good morning. So this one's all pretty simple. We traverse level by level until we hit a node that we cannot go left or right. Then that's the minimum, because that's the dead end. So in this case, we don't care about the next node, even if there is a next node. But we can sure the next node is gonna go to the next level. So therefore, once we hit that node, then it's the minimum depth. I'm soloing fast. I mean, yeah. I think I'm getting. It's both getting better, and also I think this is kind of easy. Didn't get a chance to discuss this with you last time, but what's your motivation for doing programming exercises? My motivation right now is find a job. I'm interviewing companies right now. Especially like the big companies like to do these kind of questions. I mean, I think there are still companies that want to do practicals. I really want to become software engineer. Yes, I was a software engineer until I got laid off. But yes, I am a software engineer, and I'm still a software engineer, I guess. Yeah, I've been laid off since last year, but after that, after the layoff, I've been just doing streamings and chilling and playing video games. Yeah, I think I need to get back to a job right now, because streaming doesn't give me any money, unfortunately. What kind of job I do? Web application development. I mean, I am getting like some interviews from like big companies, so that's why I'm preparing. That's why I'm preparing right now. Rather full stack, I do full stack. But if I have to choose, I think I would go for. I think I'll go for backend now if I get to choose, like, because full stack basically means you have double amount of work, not double amount of work, like double amount of things that you need to get updated to. So right now I'm either looking for full stack or backend. You know, full stack being front end and back end, which means you have to stay updated for both front end and back end. I mean, when you are young, I guess it's fine, but like, for long term, that's slower learning, especially with the tech evolving so fast right now. Do you prefer giant flag or the with flag? Or startup? Right now I try to get into fan company. I think they probably not call fan anymore. Facebook, LinkedIn. Wait, LinkedIn is not. Wait, what do you mean LinkedIn? You mean Microsoft? Yeah, I have interviewed at Facebook, Google, Microsoft. Wait, for some Amazon as well. Wait, did I interview at Microsoft? I don't remember. It's for some reason Apple never got to me, probably because I'm more into Windows stuff. Wait, hold on. I think I spoke to Apple before. Top giant companies. I think your L shouldn't belong there, because LinkedIn is not a giant company, ever. LinkedIn is right now belongs to Microsoft, but they were never a giant company. Also, Facebook, like, you shouldn't call it Facebook anymore. It's called Meta. Anyways, given a root of a binary tree and an integer key, find the level order successor of the node containing the given key as the value of the tree. The level order successors the node that appear right and left of the node that appear right after the given node in the level order traversal. Given node is 3. The next value, okay, so doing from left, right. If the key is 3, then the next value is 4. If key is 9, the next value is... Okay, this is also easy. Oh, it can be a root as well. Okay, so same thing. We want to make a stack. Let stack equal to roots. While stack is no NT. Size equal to stack.size. Stack.length. For let I equal to 0, I less than size, I plus. Okay, so in this case, we're looking for the root node. So we can do a stack and then roots is false. And then constant node equal to stack.shift. If there's a left node down, we push the left node. Stack.push left. Node.left. If there's a right node, then we stack.push node.right. And if roots, do I need to do this multiple times? If we found a root, then we just push the next value. So if root, then we just return stack.shift.val. Right, so now we just look for the root. So if no .val is equal to t, then root, we found the root. Actually, we don't need to do that, since we're looking for it here. So if no.val is equal to g, then we just return this value. Run. Recall rule has been because I'm using both roots. So remove this one again. Cannot read property of undefined length. Stack is equal to roots size dot length. Assignment constant value. Noise size equal to stack dot length. Cannot read property or undefined within length. Stack is undefined. Console log stack. Value is 1 left and then right now. Value is 1. Right, so stack dot length is fine. Assign to constant value. No dot val. Stack dot length. Run. 1. This is fine. Let okay, what's wrong with this? What's wrong with this? Cannot read property or undefined within length. There's no length here. The only length I have is here. Return this dot and dot length from. So there's a left node, there's a right node. Next random, what is next and random? Why? So what's wrong with this? For the size of the stack, we're gonna push them, and every time when we shift a node, we're gonna push the left and right if possible. Or maybe this could be the last node. But we're talking about the first test case. So we are talking about first test case. So the next node should be 2. Right, node stack dot shift. Shift is 1. If node dot value is the key, then we shift the val. Because we are pushing left and right, so 2 and 3 will be in the stack at the moment. So when this node of val is the key, then return shift, we return 2 dot val. So this is correct. This should be correct. I don't understand. Cannot read property of undefined. Is this game? I mean not game. Is this thing bugged? Lesson 5, C++. What if I remove this? Run? Okay, something wrong with this part. if node.val is key, then we return stack.shift.val. So this is after the stack is pushed. We return that value. If node equal to value, is this what you're looking for? Ah, the key. Ah, so they're not looking for value, they're looking for the key. Output is 1, return shift. Run this. Oh, actually no. They're still looking for that. It's not doing that because the node is never equal to key. If node.value is equal to key, console.log stack. If it's equal, then we log out. So stack, the first item in the stack is 2. Right? So we do stack.shift. Run. So this should output 2. Shift, right? And then stack.value should give me 2. Right, it gives me 2. And they're looking for 2. So I just return the 2 then. But this is saying what the fuck? So we know this is 2 because we just console logged this. And they are looking for 2. So we're returning this. Crash the program. Yeah, I think the program is issue. Oh, you don't return value. You want me to return this? Run? Ah, what the fuck? Ah, they want me to return the node, not the value of the node. Fuck. That was... Yeah, this is the kind of question you don't know, like what the code is expecting. Submit. Accepted. Yeah, I think it's not my code. It's the test case that they're doing. Basically the test case is looking at that node, and then they're doing the node.links. Some part of the test case they have that node.length. But I mean I think they have the nodes and yeah, I think it's node.length somewhere. But since we are pushing the value, I mean we are returning the value into the from the function, and the test case is looking at expecting a node, but they're not expecting a value, so they try to do a length of that value, which is like that creates undefined. I think that was a problem. So the code is fine, just like we didn't know what the test case, since like they have something here. I don't know what they have this year, but we cannot see the test case, so we don't know what they were expecting. Basically that. Next. Yeah, they do a break. You're not familiar. It's not JavaScript. It's any language. Any language. Since the test case is expecting you to return a no. But in my case, I'm returning the value of the no. So that's why it crashed. Next. Connect level order siblings. Given a root of the binary tree, connect each node with its level order successor. The last node of each level should point to a node. Node. Given a root of binary tree, connect each node with its level order successor. Connect each node's level order successor. The last node of each level. I don't get it. You have a roots? How you want to make it into a binary tree? I mean, you want to make it into a linked list, I guess. So 1 is connects to node, and then 2, 3 connects node. Okay, tree node. You want to create tree node. You want this. Left is this. Right dot this to next. It's still doing zigzag, except each level you want to point to the next. But how do I point to the next? Class treat node. So I guess in the node constructor there's a new thing called next. Okay. Okay, let's start with the same thing. Stack equal to roots, while stack dot length. Constant size equal to stack dot length. While let I equal to 0, I less than size I plus plus. Why is it squiggly? Let I while while 4 let I. I think what we want to do is first this is traversing through every node. So for each node we just point it to next. We just have a next pointer. Constant node is equal to stack dot shift. If there's a left node dot left, we're gonna push stack dot push node dot left. If there's a node dot right, then we stack dot push node dot right. So, and then lastly we are going to create current node Not current. Previous. Previous no is equal to this no. If there's a previous node, then previous node dot next is equal to kernel. If there's a previous node, then otherwise if I is equal to size if I is equal to size like what was the question expecting? Output is this. If I is equal to size minus 1, then the kernel next is no. I think that's it. Run. Cannot access previous before initialization. If size is greater than 1, then we'll do that next. Cannot access previous. Let previous equal to no, and then we're gonna reset previous, run again. Assignment to constant value. Right, within a traverse tab, we look at the first node. These are the normal stuff. And if this is the first node, I mean, if the current size, this edge case, if this is the last node, then the next value will be no. If the size is greater than 1, wait, no size greater than 1. If I is greater than 1, yeah, next. If I is greater than or equal to 1. Actually, if I is greater than 0, should be. If current 1 is greater than 0, that means we already traverse one node ahead, which means we already have a previous node. So we have the previous node dot next equal to current node. Yeah, this should be right. Assignment the constant value. No. Dot next. Let's. Oh, okay. Previous is constant right now. So let previous equal to no. Run again. Correct. Submit. Correct. Yes! I feel so smart. So this one, to rest to the node, you add a node to the stack. And if this is the last node, then we point it to node. If this is the second node, then that means we have a previous node. So we have the previous node to point to the next node. Yay! So next one will be depth first search. So many of them. Map is island map is kind of popular. Treat coding challenge. Here's the island. Find the quickest path to the island. From one island to next island, something like that. I've done it before, but I probably already forgot. So let's see. Initialize stacked. Next one, you look at that. Yeah, I mean, like, you don't really get to touch any of the, like, you don't get to use these kind of algorithms in real life. So once you get a job and you don't use this, you just forget. Which is what makes me hate about like this kind of coding interview, because they are not testing you on the real life coding. Remember, like, you guys, you probably heard of this kind of story before, where a popular like developer that created like a framework or library that has millions of downloads, and they failed to get a job at like Google or something because they couldn't traverse a tree. I feel that like that's dumb. I mean, they wanted. I think they just wanted to go with an easier route. Because they get so many applications, and they want to filter out like people. But even like that filter is not perfect. Like you can have someone that's very good at codings, but they just don't do these kind of coding questions. Usually the low-level libraries handle this. Yeah, a lot of programs they already have built-in functions that does a lot of things. For example, why do you have to for example, you have I think whatever coding language you are using already has a built-in sort function, which can sort from the smallest to largest number, from largest to smallest number, that kind of stuff. But however, in a coding, they want you to build that sort function, which is kind of dumb. Like it's already been solved. Why have to reinvent this thing? Software development is very different from solving programming puzzles. Yes, exactly. That's what I'm saying. Initialize previous node to track previous node traverse pop. Since previous node is null, update the current node top. Update current node top. Include this. Then you pop one for the current since previous node. 7 is not null. Set the previous node next equal to current and link them. Update this. Yeah. Can I do your homework? I'm gonna charge you a lot of money to do your homework. Should I do one more? Performance does varies depending on the algorithms libraries developers select, but usually it doesn't matter much when develop. I mean, when you select libraries, you generally look at the. I mean, I guess you can look at the library efficiencies, computation times, but like nobody selecting a library is gonna okay, I'm gonna look at every code in the library and make sure that it's efficient. Nobody does that. Like they probably already have like they're not diving deep into the library to see how efficient the library is. They probably like select 2 libraries. I mean, the best case you do select 2 libraries and then you given them few cases, and then and you measure how much time it takes for each library for these 2 libraries to come up with the answer, and you select the one that's fastest. So yeah. AI is really good, yeah. I mean, instead of paying me, why don't you just use ChatGPT? Right? Connect all levels, siblings. Oh, so this is the same as previous. Instead of pointing to no, you pointing to the next. Okay, this should be easy. Let's stack equal to root again, while stack.length. Oops. Constant size equal to stack dot size. No, stack dot size, stack dot length. For let I equal to 0, I less than size I plus plus. We also need a previous node. So we initialize previous node to no. So function node dot stack dot shift. Again, we're looking at if there's a node dot left, stack dot push node dot left. If there's a node dot right, then we stack push node dot right. And then let's take care of the edge case. If oh, I see what the problem is. Oh, we don't care about that. If there's a previous, then previous dot next. Next is equal to previous dot next is equal to previous dot next is equal to current node. And then we update previous to equal to current node. And lastly, once we finish this while loop, we can set the next previous. Previous is equal to no. Because this is the last edge case. This is always this. By the end, like after we finish, the previous will be equal to the last node. So we just have the last node point to no, since they're asking us to point to no. So run this. Previous is not defined. Oh, because we define it here. So we take this out. and then run this. Accept it, submit, accept it. Easy! Yay! Oh my god. This is a new achievement. Look at how many questions I did in this one stream. Like yeah, so this one is just basically we make a stack and then we set the previous node equal to the current node. And whenever there's a previous node, we have the previous node point to the current node. And we keep doing that, and then we keep pushing the stack. We keep popping the stack and then pointing the previous node to the current node. And then there's only one edge case. Is after they're all finished, the last node would be the current previous node will be equal to the last node, since we're updating the previous node to current stack. After this finish, we break out the while loop, and then we just have the last node point to node. Let's see what they did. I think they are. Oh, they're doing Q and Q. We don't need to do all the Q stuff. Oh, that's why they have these. They're using class in Q. They're probably doing this because JavaScript JavaScript has kind of built-in stack, which is just array. But they're probably doing this because there are other languages might not have a built-in stack. So they do a class that enqueue DQ for you. So well, it's they're doing this previous node if it's no no. And if you have a left, then you push left. If I right, push right. Previous node next is current. Previous node is current node. Yeah, basically what I'm doing. But the problem is, how did they deal with this no thing? They are not adding anything that's no. Or is it by default the next? Oh, I think by default this is next is no. That's why this still passed. God damn it! I took care of the edge case and then, but this program already they already defined the next to be no. So let's see. If I remove this, it should still go through. See, accepted. God damn it! Accepted. So I didn't even need to do this. I should know. Previous. This should be previous. Don't next is no. I didn't even need to do this because the next is initialized as no.主播，我去吃饭了，面试生你。好，好，你慢慢吃。我也要结束了。I'm done. I'm done for now. Should I play a little bit Master 2? How about adding some comments in my code? Normally I mean in a real world coding I would do comments, but this is just like nobody's looking at this. Like I'm not looking at this I'm not gonna be like look back at this in the future. So comment is pointless. Anyways, I'm gonna end the stream here. I'll think about Macedo. Maybe I can play a bit. Future he wiped out here today. Haha. uh uh I don't think I will look back at this. I mean, in a real world coding, I will. In a real world coding, I will look back at my code, like, cause we want to do modifications. But this is coding challenge, is different than real world coding. Like I said, like we discussed before, this is not real world coding. You hope there's a Macedon string. But it's kinda late for me. Okay, fine. We'll try to do 1 hour. I will do 1 hour Macedon. Let me schedule that right now. Gonna schedule 1. And we still be playing Memento right now. I think either I'll play Memento or Branded. I'll think about it. Next. I'm gonna set it to 25 minutes from now. Done. I'll get there and copy. Yeah, I think after this I'm gonna go grab some food. And I'll go grab some food just so I don't starve. Here's the link. And here's the link. And the version of Memento. I think Memento is kinda complicated. Not as complicated as Branded. I like play complicated deck. I mean, I think I like or anything that's like uses the brain a lot, I guess. Anyways, see you guys later. Bye bye.